Hello and welcome. I'm Bill Wake. We're working on Parser Combinators this week. It's an approach to writing parsers that comes from the functional programming world. And the idea is you write some very simple parsers and then you write some high order functions that combine parsers to get interesting things like alternation or sequence of items or repetition or so on. We've hit a wall and I've got a couple of ideas to get around it. I'll show again what we're struggling against, but basically when we have items formed by sequence operators, the type of the item is as complex as the length of the sequence. So if it's 3 items in a row, there's a type that's like A containing B containing C. If there's 4, it's A contains B contains C contains D. Then when we want to combine those to say this alternative or that alternative, they're different lengths, and so they have different types because they're different lengths, and we can't. They're not comparable or they're not compatible in that sense. So the two ideas I have, and they're both a little out of my normal range, so we'll see what happens. But one is that Swift added this keyword called sum, and we'll look at what it does in Swift UI, but basically it tries to say, I know you're going to return some complicated type, but I just care about like the top level type of it. And if you return that type, I'm okay. So in Swift UI, if you have a view, one view contains 2 items, and another view contains 3 items, and you want to combine them into a larger view, well, you want those types to be compatible, and sum gives you a way to kind of ignore the complexity of the type and just get to the kind of end result of it and say they're compatible. The second way is I ran across another implementation that they had what they called a type erasing function. So I assume the idea is you're going to kind of not worry about all those A, B, C, Ds, but you're going to focus on the end result and kind of run this through this function at the end that gets rid of all the ABCDs and just simplifies it. I don't know. Maybe it works. We'll see. All right. So let's see. So kind of starting back at the top, we're doing this in a playground. So we you can execute stuff right away and so on. So the starting point I have is if I want to form expressions, I want to make this type with indirect enum can form a tree of expressions. So I can have a number, or I can have, say, a plus. I could have opt2 plus a number and a number, or I could opt2 plus a number and an opt2 that's a times and 2 numbers. Okay, so it builds up arbitrarily deep trees. Let's see, here's an example of that last. Plus 9 and times 9, 2. So this is 9 plus 9 times 2. And that's sort of the, this is my analog for the parse tree that we produce that in a compiler. So, there's some representation of the syntactic and nesting structure of our language. All right. So to do this, we've got this parser protocol, and this associated type sort of makes it generic. It says you're gonna definitely, your parser is going to include a function that takes an array of characters and an index and returns to me a target, which could be expr or it could be some other type, and an integer. These 2 integers are positions. So this is the position you're starting at when you parse, and this is the position when you finish. So if I match 9 at position 0, so I have the character string 9, character array 9, and 0 index, the result is going to be well, maybe I match to a string. So it's the string 9, and the position is 1 since it moved past that character. Okay, so we need some simple parsers, the sort of seed parsers that don't call other parsers. So they're just sort of the base level parser. So I've got this one match, and we'll let you either give one character or a range of characters. So you could match a plus or match 0 through 9. Okay. And we have to have a parse function. So the parse function takes the characters and the position and produces a string. Well, it's an optional string. If it fails, it's going to put a nil out there saying I didn't match anything. If it succeeds, then it returns position +1 because it skipped past that character, and it builds a string out of the character. This is we're not as efficient as we could be at this point or anything. I'm not worrying about efficiency. I'm just trying to get these types straight. But this is a very simple parser. Here's match plus. So it's going to look for the character that we specified. Here's times.parse. Okay, input 3. Okay, so starting at position 3, 0, 1, 2, 3. Match times the times operator. All right, so let's run this far. Hopefully it'll ignore errors till there. No, it won't. Okay. I played around a little bit last night. Okay, we were back at line 50-ish. Okay, so let's run here. Okay. If we look, I don't know why this doesn't display properly, but probably because Playground just always has problems. I don't know how you missed this. Okay. But what it returned was a pair. The .0, the first element, is the string star. The second element is the index or position 4, because we advanced by 1. So that does what we think it should. Okay, let's skip over and then array. This one is and then, so it puts two parsers in a sequence. So now we're getting to the combinator aspect, which says we're combining two parsers to build a bigger parser. So we've got parsers of two different types. We don't care what they are. And one's a parser 1 and one's a parser 2. They all are parsers, but we don't care about the exact types. We're going to take parser 1 and parser 2 as arguments. So these are the two things we're going to put in sequence. And how do you match two things in sequence? Well, you try and match the first one. That gives you a new position. And if it failed, well, then you just return nil. If it succeeds, we'll try and match the second one starting at position 1. All right, and position 1, so that's where we ended up after we matched P1. So we try and match P2. If it succeeds, we return an ordered pair, the first result, the second result, and the final position. All right, and if it fails, then we fall through here and return nil. So this is an basically gives us sequences. Here's the example: digit then plus, and sequence 1 then digit. So it's digit plus digit. And if we parse that on our input, if you remember, it's 1 plus 2 times 3 or something like that, we'll get a match. Let's see the contents. Oh, so funny. All right, and I can just open these up. So 1 plus 2 plus 3, basically the overall answer is this nested structure. Here's 1, and here's the plus. Okay, so that was our target 1, target 2, and then the position is 2. Okay, and then we have, let's see, this is 1 plus. Okay, am I misunderstanding something? I would have thought the 1 plus 2. Oh, yeah, here's the second 2. Okay. Yeah, 1 plus 2. And so it's a nested tuple. So the first tuple is 1 plus, and then the outer one is 2. And if we had plus 3, plus 4, and so on, they would form deeper and deeper nested tuples. And then the overall one, we finish at index 3, you pick up at the times, whatever. Okay, and then finally, for this sequence parser, we're going to create an operator that lets us write these sequences more easily than this kind of stuff. Okay, so this is borrowed. One of the resources I mentioned was a talk by Scott Flashen, and he used this notation. I don't know if it's borrowed from Haskell or what, but he was doing F#. But it's sort of the graders suggesting appending, or, A followed by B. The dots tell you we return both values. So if you want to make this operator, you just say, well, this is really P1 and then P2. All right. And ignore the array stuff because that was a failed attempt. But here we've got digit followed by plus, or digit followed by plus followed by digit. Both legitimate uses. It's multiplication precedence, so it's going to be, relatively high precedence and left associative. And that's why our innermost nesting is the first entry. Okay, a second combinator is or else. So this is like an alternative. And notice there's only one parser type, because if you're going to match this or that, they both got to be the same in some sense, or you can't really, it doesn't make sense otherwise. So we create P1 and P2, we hold them, and then to parse, it starts out like the other one. You parse P1, but and if it's not nil, you just return it right away. So you're just taking the first alternative that matches. The second alternative, then, if that doesn't work, try P2, starting back at pause. So in the other sequence one, we started at pause 1, but here we're saying, I gave up trying to parse that with the first rule. Let me try the second rule starting at the beginning. And we get a result there. And if it's not nil, then we return target to pause. And otherwise we give up and say, I can't parse it. I can't find an alternative that works. And once again, we can make an operator that's, in this case, less than bar greater. Bar, in Boolean algebra, right? You say A or B. That's more or less what you're doing here. It's just in the algebra of parsers. You can think of it that way. All right, so I can say match a digit or match a plus, and array and should fail. So we get a nil back. This one matched 9 at, and position 1. Position 1, because you passed the 9. This one matches the plus. So you can see that it is happy to do that. It matches it if it can and nil otherwise. Okay, I'm going to skip many because we don't need that to show the problem here. We're working our way down there. All right. I guess I'll mention this one. Bar greater is basically says call a map function. So I've got this parser. I want to get a different value for it. So in our case, we returned a string for our matching our single character. But if it was an integer, we might like to know the integer value. So we could pipe that to a function that turns it into an int. Okay. And, we can go through the mechanics of it, but we won't. And so we've got a couple helper functions here for us, making our expression type, our parse tree. We can make a number that's just a simple number, or we can make an operator, string, expression. Okay. So build the tree. All right, and I defined a version that takes the nested tuple structure that we have, okay? So this one pulls out the expression, the op, and the argument from that. Okay, now let's see if I can find where things go sour. Yeah, I think this tells us right here. So let me run this far. Okay. Well, okay, I left something complex in here. This and then array thing, I was trying to trying to make things work with arrays and get around this problem. But let's see if I find the and then array. Let's take this operator out. I don't know what'll break, but we'll see. And then back down to the bottom. Okay. Run to here. Okay. So if we say NF, it's a digit, and then we pass it to make number. Okay. So the type of this is it's a pipe going from a match to an expression. So digits to match, and then the make number function turns it into an expression. In this case, a dot number. Now this one is parenthesized expression. We want to match the left parenthesis, an inner expression, and a right parenthesis. Okay, and the type of this, okay, complicated. It's a pipe, and then match, recursive, expression, match, and expr. Okay, and so what we've got then, like, this is obviously more complicated than the pipe match expression that we had on the other one. And that's where we get the problem. So we'd like to be able to say a factor is NF or PE, and that's going to be an error. Okay. The type is ambiguous without more context. So the problem is it doesn't know what to do. I think the problem is, I should say, error type. Okay. It doesn't think it can combine these two, because this one's pipe of match expression, and this one's this complicated expression, and the two parsers are supposed to be the same type, and yet they're clearly not. All right. Now, they're clearly not from the mechanical point of view, but the end result is both of them return expressions. You know, they are complicated, but they both return expressions in the end. So we had return target and int. The target's expression, like, that's reasonable. Okay. So all this is just kind of catching up to where we are and kind of articulating the problem. So what I want to do, right now, I would say this one's at a dead end. Okay, so where we are so far is a dead end. So what I want to do is try this sum keyword and see if we can figure out how to make that work. So let me go back over here. This, let's see, it's really just our hello world. Okay. So it's, well, let's just run. So this thing is a content view that's a view, and it's really the top level view. It says I've got a body, which is some view, and what's in it is text hello world. I don't think I need that. Okay. And so, its type, let's see, will it tell us that? The type is some view. Okay. But the type of this, I don't know if I can, let's just do this. The type of this is text, which is a view, and I don't know if I can get it here. Oh, that's the function. Okay. But at any rate, hello world, wherever it got to. Okay. Put it over here for now. All right, there's our hello world. Now, the thing going on, let's make a different text. Okay, we have this VStack that's going to stack them vertically. Okay, and let's put text goodbye. And close our VStack. Okay, so now I'm going to put two things in here. And I have a text followed by a text. Are you there? Yes. Okay. In this stack. So if I look at what's the type of this, he's a VStack of content. So his type is VStack. It's not text. And this sum view is sort of protecting us somehow. And I'm, like I said, I'm hanging on with my fingertips here with this. This is called an opaque return type. And so way I interpret it is it promises to be a view. It could be any complexity thing. This is a stack of text, comma text, okay, is kind of the ultimate type of this thing. And we don't care about the fact that it's this complex or that other complex. And I could put stacks in stacks. Okay. And so I'm mixing something, I'm building a nested structure here, arbitrarily nested. These two things, the VStack and the text, have different types, but the VStack has no problem with that. Okay. So, and this is all because of this sum view kind of hiding the complexity of this and saying, well, it really is still just a view. All right. Let me see. I don't know if we can we get there? Right. Okay. So associated type body is a view. And I'm going to ignore this, but you must return a body to provide a content with your, Swift views and other views. And you have this variable body. Okay. So its type is self.body, which is view. All right. And we're using this sum keyword to, it's legal to do that. We're saying the type is not just view, it's sort of sum view. All right. Now, my hope is the problem that SwiftUI has in building complex structures like this out of nested inner structures, it doesn't want the types to be incompatible. It just wants to manage them. And if it treats them all as sum views, it should be okay. That's my understanding of how this works. So I talked about type erasure. In a sense, I think of this as that. It's saying, the compiler will keep track of these types because it has to keep track of types. But, from the outside, it just looks like a view, and don't worry about all the complexity on my side. I'm just, in the end, it's a view. You don't care if it's a stack of text or a text in a stack or whatever. All right. So my hope is that is analogous to our problem here, where these two things have different types. And so it doesn't know how to combine them because they're different. Okay. So let's make a new playground. Probably not our last. Okay, a blank, sure. Mac OS. This will be PCOM 2. Well, PCOM some. Okay, and I'm gonna steal stuff from this one and build this one up and try and get it to the point where we care. Okay. Let's see. So what's a keeper? Well, I'm going to keep this for now. I'm going to keep the match function. I keep the protocol. And match. Okay. Okay, and then we can take, let's take this. Well, I'll take these three. Okay, plus match, and then for input, I'll do array of 1 plus 2 times 3. Okay, we run this, we should get our parse. Yes, we match 0. I'm sorry. The first component is the string that we matched, star, and the second component is the index. We went from 3 to 4. And I heard a nice little rule to think about it. Think about counting the position, instead of the positions, think about counting between them. So here's 0, here's 1, here's 2, here's 3, and here's 4. Okay. Or you can think of how many characters to the left of my index. I don't know. It helps me get by with fewer off by ones. All right. So we have our simple parser. Now I'm going to try and play with sum. I'm going to, by analogy, I'm going to return some string. Is that going to help us? Oh, it's not liking it already. An opaque type must specify only any object, any and/or a base class. Okay. Let's define a result. Okay, actually, I think enum is probably better. Okay, for us, I'm going to take a slightly different approach. Is that going to help us or hurt us? I don't know. Well, if we're successful, we're going to have a type. Let's say our type and an int. And if it's a failure, we don't need anything, maybe. Okay. And T is generic. Okay, please work. Yes. Okay. So what I'm saying is the result type, it's going to correspond to the target here. Okay. And so this, I'm going to make this return result of target. Okay. And now this needs to return some result of target. Okay, let's go back to view. What is it? It's a protocol. Okay. Well. Okay, let's hit some documentation. Do I have a page here? Excuse me one sec. Okay, let's look for Swift sum keyword. Yeah. And I really want the Apple stuff. This might do it. Lovely name. Okay. Opaque types. Okay. Opaque type defines a type conforming to a protocol. Okay, so apparently we can't use an enum without specifying the underlying concrete type. They appear as the return type of a function or the type of a property. Can't appear as part of a generic type. Oh. Opaque type is it must return values that share a single underlying type. Return type can include types that are parameters. Okay, well, conforms to a protocol. Okay, so I guess we're going to have to declare a protocol. Protocol results. I don't know if we can say associated type target. Associated type target. Okay. And then let's go back to view. You're promising to have a thing. Okay, so let's see if we promise to have a match of type target optional and a position of type int. Okay. For now. Is that going to work? Cannot specialize non-generic type result fix. What if I take this off? I think that's going to mess up line 11. Yeah. Can only be used as generic constraint. Request type, associated type. Any keyword. Okay, you can use an opaque type. Yes, that's kind of what we're doing. Okay. Associated type number. Class. Not sure. I don't think this is exactly what we're... No, somebody just wrote their answer as a blog post. This must be written using generics. Okay, can I try generic here? I thought we did that. I don't think this works. Protocols do not allow generics. Use associated types instead. Like somehow I ought to be able to get the same. What's the problem here? Oh, no, they just... Gosh, it feels like there should be a way to do this. Let's go back to this. So body is self.body, which is a type view. And this is a view. Well, that's curiously recursive, isn't it? To define a view, you've got to give me a body type that is a view. Okay. And self.body is view. I don't know if I can try this, maybe. But then the type here, return type, is the thing itself. Okay, so if I do this by analogy, they're saying target. Well, target can't be a parser. Can I say target of result? Because it has a target. Okay. Now, if I say some result, okay, maybe we're getting there. Return. Okay, now I need to make a result. Closer. String int cannot conform to result. Okay, well, yes, it's got to be a result. Protocol stuff, sure. Results, that's what I'm saying, right? Okay. Parser, target equals string. Nil requires a contextual type. Target nil. Result cannot be constructed. I don't know what the type is. Sure. All right, so what I'm trying is I'm going to create an actual value. So this is more like, this is not really an actual object, I don't think, right? It's just, I think of it like a interface definition in Java or something. But I'm creating a variable that does meet the requirements. It provides a get method and for each of them. Okay, so let's try turning parse results back. And I don't need my... Oh, come on. Direct parameter T could not be inferred. Parse result any. Interesting. Well, I think it's really target. line type match does not conform. Oh, what's the matter? Type alias target equals. I think he was just waking up. Okay, let's run this far again. No. Target equals string. And result. This is weird. Maybe my result. Target. Let's try being explicit here. Does not conform to results. Target is result. Is that? Cannot specialize non-generic type result. It's like it's not waking up. Match.target, aka string. Match does not conform. Parse result string. Okay. Oh, come on. Must specify any or a base class. Is parse result a string, not a base class? I don't know if I say any, I feel like it's going to just complain. Any. Right? I would complain. Non-matching type character int goes to some any. Parse result string, but it doesn't like that. Go with the one they gave me. Happy. Why are you happy with this, but you weren't happy with this? Okay. Cannot find input. Okay. Did we get there? Golly. I don't know what happened there. I guess something got confused. Parse input position int goes to sum. Oh, we're not saying sum here, are we? Oh, okay. Ow. Oh. It's conform to protocols. But if I just say result, I don't think it's happy. An opaque type does not conform. It's got to be parse result. Okay, I don't need this comment. I don't think I can say some result of string. And void cannot conform to result. Cannot specialize non-generic result. Right. But I can't say some parse result here. Okay, I can't say some parse result. It must specify any object protocols and or a base class. I didn't try it without this. Ooh. Any. Okay. I'm running out of things to try here. I don't know. It feels like my protocol result has an associated type. I promise to match it. If you give me a type, I make that the target type, and I return them. So that conforms to this. Parse T is a result. So I don't know why some result is not happy. It's not going to like some result of any because that uses generics and this doesn't use generics. Cannot specify specialized non-generic, yeah. Now, interestingly, this doesn't complain. All right, there's something to this then, right? Because if this is okay, and we're returning a parse result of string, the problem is conforming, not being a legitimate type. Okay, so let's go back to here. Target does not conform. So it's kind of like some result is not compatible with target. Even though target is a result. What if I say parse result? Do I need to type? What if I give it another type? Match. If I could spell that word. So target constrained to non-protocol, non-class type. Okay. I think this explains what I wanted to do as good as anything. I've got one person in mind I'm going to ask about this, but I've got to return a result. Oh, now do I need to say, oh, this, yeah. Let me put this parse function back down in the middle. Non-matching type, some result. To target. Can I say target? Okay, well, I think we're going to stop here on this part. I'm going to give up on the sum approach for now. In other words, if it's going to work, I'm really close, but I think I've tried every combination I can think of that I can't put target here. Right? I can't put target. Let me run through one more time. That's the stub they want, and that is the stub they won't let me specify. Okay, and target is parse result of string. So plugging this in should probably get the same message. If I can build. No opaque type. And that was the same message, right? Right. Okay. Yeah, I'm going to give up on the sum thing for now. Frustrating. Okay. But that's why we're doing this spike. It's extended, but we're trying to find these things out. And if it worked, I'd definitely have another tool in the tool belt for these obscure type situations. Most of the time, you don't run into this. All right. It's because we're trying to do a kind of a functional, little bit odd of an approach. Okay. Let's take a break, like 3 minutes, and we'll come back and try the other quiver or arrow in the quiver, which is a function that's supposed to be type erasing. So hopefully we can get rid of the distinction between a two-handed right-hand side and a three-handed right-hand side and make them compatible. All right, see you in about 3 minutes. Hi, welcome back. Okay, so we're going to set aside this one, this playground, pcom sum. Let's save it. Let me just add that in. Get it done. Okay. And here, to do, let's keep track of things. So some keyword. All right. Couldn't get result type to be compatible. Okay, and so the next experiment is a type erasing function. Let's close this playground. Let's add a new playground. Alrighty. And let me see. This parser is Diesel is another implementation of a combinator-based parser. So trying to figure out, something compatible to what they do. Okay, this is much more like I was thinking. So they're doing stream. That's basically, this is the input stream, the output stream, or the input stream and the rest of the input stream. They have a parse result across these two types, similar to what we're doing. So element is the result type, and then stream is kind of like our position. Stream is probably better if we can make it work. Okay. Let's see. Somewhere they said something about erasure. A type erased parser. So I'm hoping something like this can help us. So they have a parser. So this is a combinator because it's taking a parser in and producing a parser. Okay, so it takes a stream, produces an element and a stream that's compatible there. Creates a type erased parser. P, where P is a parser. P.stream is stream. Okay, P.element equals element. Okay. Create type erase from a function. Parse. Okay, I don't know what's type erased about this. Maybe just wrapping it? Okay. So all right, let's do the analogous thing. Let me rearrange these windows slightly. Okay, so I'm back to our original here, and let's take these types like we did before. Oh, lost my window. Push this up here. Okay, enum type, parser type. We only have one associated type. Oh, and something else is going on. Let's see where they define their parser. Thought he had a protocol. Yeah. Protocol parser. We just have element. Stream goes to element stream. Okay, that's close enough. Parse results. Well, we'll take this in, but I'm gonna modify it much more like we had. So let's take int parse result. We don't need stream, and I'm gonna ignore the error cases. Okay, that's basically the definition we had earlier. That didn't work out with the sums. Okay, so that's that. Parser this type. Okay, wait a minute. Associated type element, and then he returns parse result of element. Associated type target, he returns parse result of target. Okay, so given characters and ints, we produce a parse result. Okay. That parse stream parse result of type. Okay. That looks to me like about what they have. Modulo a few little things. Okay, so now I want a parser. Okay. So this class, oh well, he's got structs. I don't think it's gonna matter, but we'll call this wrap. Conforms to parser. All right, and that means it's got to do a parse, so they should tell us that. Yeah. Oh. Type wrap does not conform. Yes. Type alias target equals. Now, why don't they need the type alias? Okay, let's keep our parser. The type is our normal type with a parse result of element. Oh, this has got to be an element. Okay, so this is array of character and int goes to parse result of element. I think that's analogous. Okay. We create an initializer. I don't yet. Init of type P takes parser of type P, and then there was some where stuff, and then self.parser equals parser. Now do I have to do all this stuff? P is a parser. We don't care about the stream, and the element equals element. That all sounds okay. Cannot assign. P, what's P? Any type. Okay. I don't know if I can. Parsers type P. P is a parser. P.element is element. What's the problem? Element is not a member of type P. P is a parser. Parsers do not have elements. Target. element is not a member of type P, because P is a parser. Parsers have targets. Maybe we can make this element. Use the same word throughout. Parser type is P. Character int goes to parse result of element. Parse is character int goes to parse result of element. Maybe I have to do element here. Target. That doesn't sound right. No, I'm messing myself up here too much. Wrap. Make this target. Make this element. Element equals. Cannot find type. Yeah, right. Okay, I am screwing myself up so fast here. Okay, if I have a target type. And let's just call this, I don't know, V, E. The target type of the parser is whatever we're wrapping. P.parser P.target equals, I think that's E. And this is target. Cannot assign P to type character int. P.parser not conform. Add the target. Parse character int goes to parse result. Oh, well, I certainly do need to add that. But this is frustrating. Okay. Cannot assign P to type character int goes to parse result of E. I don't want to cast it. I mean, I don't think I should need to. Parser is character int to parse result of E. Init the parser type. P's got to be a parser. P's target should be E. Yeah, let's just try it. Okay. And then the code, I think we're just calling parse, right? Oops, this way. Yeah. Parser.parse. Input. Position. input and position. Has no member parse. Oh, it is a function, so we just call it parser. Oh, well, maybe this is parser.parse to get to the function that is inside it. Okay, that seems plausible. Oh, let me call this parse function then. I'll just take the abbreviation for now. Okay. All right. Does that build? I'm not seeing, like, it seems like the type is going to be wrap of E, right? But maybe that's okay. All right. So if I say let digit equal match 0.9. Okay, so match any digit. And oops. Oh, I've got to pull a match function in. Well, this may not be straightforward. Okay, match parser type alias equals string. Sure, parse goes to parse result of string. Position goes to parse result of string. Okay. See how that does. 3913. Oh, they need to be parse results. Okay, so we got digit. If we do digit.parse of 7, 0, and digit.parse of array of ampersand 0. Okay, run that. Good. Okay, success 7, position 1, and a failure. Okay, so I think this parse result type is moving us closer, moving us in a good direction. I think it's a little more abstract, and then we can, I don't know, I think it'll be okay. All right, now if I look at digit, what's its type? It's match. All right, so now I want to say let W1 equal wrap of digit. This type should be a wrap. Match.target. Okay, I would have expected string, but we'll keep going. Let W2 equal wrap of digit. I I don't see any erasing going on here. What? Create a type erased parser for my function. Create a type erased parser from an existing parser. I didn't pull that bit in. Okay. How is this type erased? Okay. So we create parse digit from a string, producing a character and a string. Okay. If the character is number, if it's not a number, I guess the character doesn't exist or it's not a number, return an error. Otherwise, success with the string, character, and the rest of the input. It defines an interface for types and combinators. Digit may be routed to provide these combinators. Parse 2 digits. Make an any parser out of it, and then you can use it. Right. So the reason I've been using pause, position, I could use substrings, and that probably would be the right way to go. Stream-based stream. Okay, let's find any parser. Okay, that's those two. We create it. Oh, that's many parser. Okay, any parser. Many, any, surrounded by. Parser that parses this element, surrounded by elements of a given parser. So, character B surrounded by A's, by many A's. A, B, C, C, D. Success. Okay. Parser, then self, then parser. I don't know. Okay. I'm not sure why he describes this as erasing the type. Okay. Let's see what else they got. I think he had some test code as well. Many. Digit.parse 0 succeeds. Assert parse 0 succeeds. Digit.parse. Okay, there's the function. Right. Did they pull that? Well, I don't get it. Let's find that simple parser. One or many repeat, transform, combine. Well, I can see that it parses. I guess that part makes sense to me. Why the any parser is needed, though? Okay, let's try parser tests. Nope. Parsers. Digit parser. Parse stream. Resulting in a character. Okay. Digit equals digit parser. I don't know. You call digit parser.parse. It seems like you would get a character result. Parser.parse. Digit. Any parser digit.parse. Okay, what else do we have here? Assert that. No, that's... These seem okay. Yeah, I just don't see what the any parser is giving us. My hope was these types would just be wrap. It would be just like wrap returning string or string in our case. Oh nope, character. No, string. Sorry, parser result of string. So I was hoping for a parser. I would hope this would be a parser of strings. And yet the type is complicated. Well, let's pull in our alternation, or else. So we did this parser. Now, I did class. I don't think there's any difference if I do struct, but maybe there is. Well, let's comment this out for a minute here. Maybe that does matter. Let's stop, run. Oh, it is significant. Okay. W1 is wrap match target. W2 is wrap. Oh no, that's still. What's this though? Wrap of string. I don't think I can say some here because we tried all that, right? Succeeded. Oh, there. Okay. Yeah, so that's not going to do it. But it's interesting to me that this is a wrap of string, that maybe this or else thing will work. Okay. And then I'm going to have to figure out why it's actually stripping out. Okay. So or else, let's take, okay, P of parser. Add protocol stubs, sure. Character int goes to parse result. Okay. Invalid redeclaration of parse, yes, okay. All right, and now this is let result 1 equals this. And then I don't know what's the best way to do this. If I want to do a let case dot success of takes a what? Takes an element and an int. New position. If it is a success, then we want to return result 1. Let the case. Or I can say if let success. I think I can do that. If case let. Okay, fine. So it doesn't disappear necessarily in a switch statement. Okay, so parse the first thing. If that succeeds, return the result. And we don't even need this stuff, I don't think. I think we can do it like that. And then I don't need the lets at all. Okay. So if that succeeded, that's fine. And then I think we just go on to parser 2. Otherwise, return failure. Okay, and it's not complaining about types. Thank goodness. Parse input character position int, here's parse result. Result equals p1.parse. If it's success, return it. Otherwise, fall through, try p2.parse. If it's success, return it. Otherwise, failure. Well, if it's not success, it's failure. So I think in this case, we can just return result 2. Which is really just p2.parse. Okay. All right. So try p1. If it succeeds, return it. And otherwise, return p2. All right. I think that's okay. Let's run. Now, I've got digit and W1, W2. All right, so can I say, let example 1 equal digit or else of digit and W1. Or else takes 2 parsers. I've got digit and I've got W1. Their types are different. Oh. Okay. What if I say W1 or W2? Conflicting argument types. Oh, no, that one's the same. Oh. Now, W1 and W2, I would have thought would be different. Okay, let's make a W3 is wrap of W2. His type is all this, but when you run it over here, it says I'm just a wrap a string. So I think we can say example 2 equals or else W2 or maybe 1 or W3. And still be okay. Alrighty. Let's pull this operator in. W3. Okay, so I'm saying any of these wrapped ones could be it. And oh, it's still fighting. The first one's okay, but the second one, it's got an or else versus our wrapped up thing. I don't know if I'm... Okay, let's try this. P of parser. If we have P1 of or else, P2 of parser, is that going to work? wrap P1 and P2. I don't mind bearing the complexity in here for sure. Yeah, representative type or else requires arguments. Yeah, that's gonna go bad. P parser cannot find. Expected greater. I'm not sure where the greater is supposed to be. Or else takes a parser type. Maybe just or else P? Promising? Or else wrap P? And it requires P and or else P to be equivalent. I guess that's a complaint about the wrap. I don't know. Is that a knit with two arguments? Requires P and P dot P and or else P dot target to be equivalent. P and P dot target. I don't know. So what I'm trying to do is create a new operator that's gonna assume the left-hand side is already an or else because it did this part. And if I try an or else with any other parser, the result is an or else. Maybe it's just P here. Cannot convert wrap or else P of target, which is wrap of P dot target, to expected type P. P is I don't know. It's going to produce a wrap, right? Or else of a wrap should be a wrap. P dot target. Okay. Run here. Oh. Man, we got through this thing. Does struct matter here? Well, let's go back to class. I mean, struct is probably better if it works. They're lighter weight than classes, and we're not inheriting off of these things. Okay, let's see this thing. Well, that's kind of messy. Well, we can certainly call let result equal ex3.parse array of 371 and 0. And we're just going to parse the 0 with the first, or the 3 with the first available 1. Success of 3, 1. Okay, what the heck is going on here? So the weird thing is, okay, this is what I was hoping for, and it seems to be what I have. I mean, when you ask it, what are you? He says, oh, I'm a wrap of string. I'm a wrap producing strings. Okay. And I don't care what you gave me. I'm just going to return the type of the inner one. When I look at the variables, they know their whole complexity. I'm a wrap of a match. I'm a wrap of a wrap of a match. So I don't know, like the complexity is still there in the type of W2, but when it looks at it from whatever perspective this view is, it just says wrap a string, and that's what we want. Okay. Now, I don't know what. Well, I'll tell you what this may give us. Let's see. Let's add in our and then. Oh, this may be messy. Okay, so he's going to look a lot like it. Type alias target equals, and we're saying it's a pair. We'll need a parser stub. Okay, so it has to return parse result of the pair. Yuck. Parse result of the pair. Okay, and this is producing parse result of the pair. Okay. Okay, so let's let I think I need to do this. If case let target success target one position 1 equals P1 parse input pause, then I'm going to do some stuff because I'm happy with what I got. Okay. Otherwise, this is a sequence operator, so if nothing else, then I return failure. Okay. Return dot failure. Okay. Now I've got the result of parse 1. I want to do I want to do if case let success of target 2 pos 2 is p2.parse input starting at pos 1. Okay, input starting at pos 1. So p2.parse input pos 1. Okay. Then if that succeeds, we want to return success. Now we need the 2 targets and the resulting position pos 2. Good. Okay. And we'll take the operator. Okay. Now, this should build. And then P1. It certainly builds up something. It still builds up that horrendous tuple we saw. So we haven't cured that. But let's see if we can start building our expressions again. So I got digit, make number. Okay, let me, I guess it's this that really got us. So here's this. Well, let's try let example 3 equal, let's say digit or this thing. Now, okay, let's just make it digit for now. Okay. Cannot be applied to match and then all that stuff. What if I do a wrap? Of all this. I don't know. I think it still might be a problem. Okay. I don't know where it's starting to go bad. Line 48. No. 133. Okay, can I clear this? Let's stop. Oh, there's a way to do it. But, okay, that. And it requires target. Okay, string. But if they were, it might work. Okay, so let's pull our pipe in. I think we're making progress. It feels painful, but the map. Oh, let's take these two as well. Let's get these functions. This. Okay, make number, make up. All right, so those functions should be okay. We'll take out example 3. Keep it there for a minute, but I want to find our map. There it is, pipe. I'm going to name it map. I don't know, map is already kind of taken, so maybe pipe's a better word. Okay. Apply. Parser and value. The target is value. Fix protocol stubs. Parse result of V. Okay. So you give me a parser and a map function. I will parse it and apply the map. Okay. So now I got to decode my parse results better. Okay. So let parse result equals. Okay. So I think we can say if, how do we do it up here? It was just if let, right? If case let. Okay, if case let success with a result and a new position equals parser.parse of input position. Then we matched. Okay. So if we don't match, we want to return dot failure. Okay. Here we want to return function success with function applied to result. Result's a bad word. Let's use value like we did before. Value and keep new pause. Okay. Okay, so if we parse from input position and we get a success back, then we just want to return success with the function applied to the value, and that's that. Okay, and then we had an operator for this as well. That was that pipe. Okay. And we called it apply this time. Apply PV. Does that sound right? Okay. Yes. Okay. Now, if I take digit pipe to make number. Okay. So we're taking digit, mapping it to a number, and then I want to take this match and pipe that to our operator make op. And we want the one that takes one argument. Okay. So it's going, remember the result of this is a nested, well, it's three elements, but it's A, B nested together in then comma C. So that's the type this thing takes, I hope. Cannot find make op. Okay. Oh, we're almost close. Can I convert value spring expert to expected type and then this? It's still not quite right. Let's break it up. Let digit number equal digit pipe to make number, and let parenthesize digit is this stuff. And then this becomes digit number or parenthesized digit. Okay. Now, let's see the types here. Your type is, oh, I need a wrap. And it's already falling apart. Interesting. Cannot convert value of string expert to expert. String expert to expert to expected argument type, and then match string comma string goes to expert. Well, I think I got the wrong makeup then. I mean, it should have matched this one. Well, let's call it makeup 2. Oh. No, I don't want makeup. I want make number. Okay. This is a weird case. Let's make a new make number. Okay. This one kind of corresponds to this. It's really string, let's say argument is string, and string goes to expert. Okay, so we have to peel out just like we did down here. Well, dot number of I'm not sure what the problem is. 1, 2, 3, 4. Do I need more parens? Does this have to be inside? It's a one argument thing, so it needs its own parens maybe? Argument 0.1 gets me the first entry 0. The second entry of that is .1. But function make number argument, I don't see why this is any different. Expert, they're not experts. We want a string. A string. Let's call this make number middle just to keep our mind straight, I guess. Okay, so make number middle. Middle. Okay. Oh, close. Okay, but now I think I can say wrap here. And wrap here. Oh, I have the 3 already. Okay, exercise 4. Example 4. Or else wrap. Okay. I think we're through the dark night here. All right, so now we have a digit goes to make number. I think if I take this off, let's make a bad one. Example 5 equals DN or PD. The problem I think we have is that the types are incompatible. Now, maybe I'm wrong. No, I'm not. They just haven't caught up. Right. Ambiguous without more context. The the result of each of these is an expr. So this is really two parsers that produce exprs. If I wrap them, then they strip off all that difference structure of how they got there. This one's 3 values to an expr, and this one's 1 value to an expr. Those are incompatible, but wrapping them makes them compatible. Okay, now I don't know if I can do this on or else. Or else P1, P2 goes to, I want to say wrap. I'm wondering if I can put my wraps in my or else, or if I have to be explicit and put them somewhere else. I really don't want to put them anywhere else. So I would like to do this. Wrap a P1, wrap a P2. So anything you did just puts it in a wrapper. Okay. And so I think this is or else of wrap of P dot target. Does that work? Okay. Now I don't think I need this one anymore, because I'm doing the wrapping in all cases. Maybe I do need it more. Do I still have a conflict? No. Okay, let's go down here. Failed to parse. Operator is not a known binary operator. Okay. What if I say example 4 equals dn or pd? Back to ambiguous. Why? This one's more specific. Oh, now here, maybe this should not be compatible. I don't know. Okay, so the first case, we're saying you give me 2 parsers and I will produce an or else parser built around wrap up p.target. Give me a parser of type P . Well, I guess it's give me 2 parsers give me two parsers of the same type. Right? So if I have two parsers of the same type, I'm okay. If I have a parser of one type's an or else, and the other is something compatible, then I'm going to produce an or else of wrap. I don't think I need wrap here. I think maybe I just need this. Is that correct? Cannot convert value p.target to expected type p.target. Okay. Or else of wrap. Or else of wrap. Okay. So I have P1. In this case, or else is a wrap of something. Wrap of an expression. P2 is a wrap of an expression. And the or else is a wrap of expression. I don't know. Where's it going wrong? Down on the bottom. Let's go back to this one. Are these compatible? Well, they were compatible before. What did I have before? I think I just had, what did I have? Or else wrap. P1 and P2 are compatible parsers. Then I don't need the wraps, do I? I just had wrap P1, P2. What do we start with over here? Or else. P1, P2 goes to or else P1, P2. Right. And if you take an or else and any other parser, we're going to do an or else of wrap P1, wrap P2. That makes them the same. Okay. Is this still happy? Type of this is or else wrap. Ambiguous. DN and D, okay, they are both expression parsers. Okay, so I'm going to make a D and W. See the types on these. Wrap involving expert. Okay, let's run this. And now, before he was all happy. What is this type? Array of character int goes to parse result. Something I can't read. Really? Copy. Copy. Wrap LLDB expression. Thank you. That's not what you said over here. Array character and int. Well, that's goes to parse result of something expression, I guess. Array character int goes to parse result of expression. Okay, and they're both the same. Wrap of LLDB. Okay, so those are compatible. I could say D and W. Okay. Well, I think the next thing to try is I'm going to have wraps, it looks like, for any alternatives. What I want to do is define a postfix operator. I don't know if this is ugly, but I don't know if I can use exclamation points or something, but foo exclamation goes to wrap of foo is what we're after. And the idea is you'll make your whatever long statement you do and you'll put a bang bang at the end. Okay, so some clause will have that. I don't know, we'll see. But I think this type erasing thing, there's something to it. We're getting there. I'm still not quite clear what exactly is erasing the type, because it's showing up on the left but not the right, and the right's what counts apparently. I'm not quite sure what's doing the job, but it seems to be doing it. So it's an awkward way out, but we'll try it. The other thing I have in mind, this way. Another article, was it? Nope. This one. Sorry, don't know if it's he or she. They have a different approach where the parser is a struct with a generic that promises to have a parse function in it, assigned. And he goes through a much more, I think this is closer to the like Haskell or something approach. This little weird binder object, but I think we'll give that a try too on tomorrow and Friday. So I'm going to try and spend maybe at most an hour on this exclamation or some equivalent operator, and then take a go at this approach and see if it comes off any better. He mentioned performance problems, so I'm kind of hesitant to go too far down the path. Maybe we'll try our little array and position trick here too, but I guess if it works, then that's doable. We'll see how it goes. We can tune it. Anyway, thanks for joining today. I think we made some progress. We maybe have a path through this approach we're doing now. A little tiny bit ugly to say you've got to terminate your sentences, but that's we'll get there. All right, and then we'll also try this approach and see if we just like which one we like better. And if either one or both is good enough for our purposes, we'll keep one of them and build a library probably next week. So again, thanks for joining. I'm on next time is tomorrow, Thursday, 10 a.m. Eastern to 12:30 p.m. or 3 to 5:30 p.m. UTC. Thanks for joining. Bye-bye.